Okay, so in this video what we're going to do is find the inverse of a 3 by 3 matrix called A. A to the power -1 denotes the inverse of the matrix A. And I just want to review this notation and the meaning of it and give some basic background of the mathematics, what we're doing. So a lot of this is inspired by the real numbers. So even the notation a to the power -1 comes from a similar situation in the real numbers. Say, for example, you have the number 5, and you raise that to the power -1. Well, what does that mean? That's 1/5, okay? Now, if I take the number 5 and multiply it by 5 to the -1 power, what is that? Well, since 5 to the -1 power is 1/5, that's just 5 times 1/5, which is 1. Okay, so I don't know if you know this, but the number 1 is called the multiplicative identity in the real numbers. Okay, so it's a special number in the algebra of real numbers. And 5 and 1/5, or 5 and 5 to the -1, have a relationship. They're multiplicative inverses. Okay, so the idea of an inverse with respect to multiplication already exists in the real numbers, and you're familiar with it. So this is exactly what happens with inverses. Now, not every matrix has an inverse, but if it does, then if you multiply it with its inverse, what you get is an identity matrix. Okay, I is an identity matrix. And the same is true if you reverse the order. I don't know if you know this, but matrix multiplication is not commutative, so if you reverse the order, you're not guaranteed to get the same thing, but in this case you do. All right, so in this particular example, what we're dealing with is a 3 by 3 matrix, right? A is a 3 by 3 matrix. And what we're going to contend with is the 3 by 3 identity matrix. So I just want to make a note of what that is. So the 3 by 3 identity matrix is this matrix right here. So it has a 1 here, 0 here, and 0 here, and 0, 1, 0, then 0, 0, 1. Okay, so notice the structure of the 3 by 3 identity. It has 1s on the diagonal, and it has 0s everywhere else. Okay, so that's sort of the introduction to what we're doing. We're going to use, it's mentioned up here, we're going to use Gauss-Jordan elimination to find the inverse of the given matrix A. And that is a method that uses elementary row operations, which I'm assuming everybody's familiar with. So if you're not familiar with elementary row operations, you need to learn about that before continuing. All right, so if I were to summarize this method in one simple diagram, it would be this. I start off with an augmented matrix that looks like this. Okay, I've got A on one side and the identity matrix on the other side of the augmented matrix. All right, and I use elementary row operations to sort of migrate my identity matrix over to the left-hand side. Right, so I start with the identity matrix on the right-hand side, but I migrate it over to the left-hand side, and I'm going to have a matrix on the right-hand side, which is not A, but A inverse. Okay, so that in that way, I'm going to discover what A inverse is. Whatever is left over on the right-hand side of my augmented matrix is what my A inverse is going to be. All right, so let me start by writing in this configuration right here. I'm going to start, and this is the starting configuration, AI, right? So what goes over here? 1, 0, 0, 0, 1, 0, 0, 0, 1. And then what goes over here is just A. So maybe I can just copy and paste it. Okay, there it is. All right. By the way, I picked this example up from a YouTube creator whose channel is called PatrickJMT. He's a great YouTube creator. You should check out his videos. Check out his whole channel. You know, a lot of times his videos come up as the #1 search, you know, the #1 choice in a search. So check him out. He's a great creator. I did take this example from his video, but I'm going to work it out in an entirely different way. And the reason I did that is because I think in his example, he worked it out in a way that is a little bit too complicated. He needlessly introduced fractions, and I don't know, most people have fairly negative feelings about fractions, so I assume that someone out there would like to see how to do this example without introducing so many fractions. So one thing to note is that if you choose to avoid fractions, sometimes the trade-off is that you have to deal with large numbers. Now, so that's just a choice that you'll have to make. In this example, you'll see that the numbers don't get too big. The biggest number I think we'll have to work with is 42, which is not bad. We can handle that. All right, so let's have a quick overview of Gauss-Jordan elimination to have an idea of how this process is going to play out as we move through it. So one of the basic ideas is that you want to move column by column. All right, so we're going to start in column 1, and we're going to make column 1 resemble column 1 of the 3x3 identity matrix over here, except that we're not going to focus on changing the 2 into a 1. We are going to focus, however, on changing this 1 and this 2 into these zeros. Okay, so one of the things that happened with Patrick's videos is that he focused on changing the diagonal elements into 1s, which they do need to be 1s because ultimately we want the identity matrix over there, but you can do that at the very end and save yourself a lot of fraction related headache. Okay, so let's do that. We're gonna start in column 1, right? So I'm just gonna jump in and show you what I mean. We're gonna start in column 1. All right, and we're going to work on rows 2 and 3, okay? And again, the target here, the goal is to get these off-diagonal positions in column 1 to be zeros, like in column 1 of the identity matrix, all right? So keep that goal in mind. Always stay goal-oriented with row operations. Don't go, start doing row operations without any clear goal in mind. That's the best general advice I can give. All right, so we're targeting rows 2 and 3. So I'm going to write those targets down, row 2 and row 3 here. The way I construct my row operations is sort of backwards. I start with my targets first, and then I identify the row operations that will hit them. Okay, so there are my arrows. So my row operations are going to go on the other side, the other sides of the arrows. Okay, so how are we going to knock out the 1 in row 2? Okay, well, we're always using the row that is not one of the targets. All right, or the row that contains the diagonal element. Okay, and that's row 1 in this case. Notice that in column 1. Row 1 contains the diagonal element. Again, the diagonal of a matrix is this thing right here. So in column 1, the diagonal element is the number 2 in the upper left-hand corner there. Okay, so write down over here the row that you're going to use. That's row 1. In both cases, we're going to use row 1. All right, and then over here I'm just going to copy the targets. Right, so row 2 is going to go there. Okay, row 2 is going to go here, and row 3 is going to go here. All right, next I'm going to identify the coefficients that I'm going to attach to these rows in order to combine them to get the zeros that I want. Again, I want zeros here and here. All right, so what am I going to multiply by row 1 and row 2 and then combine to get a 0 in my row 2? All right, so let's take a look at rows 1 and 2. They're right here. So what if I multiply row 2 by a 2, say, right? So if I do that and I multiply, just look at what's going to happen in the first position here. All right, 2 times 1 is going to give me a 2. And then think about adding with this. Well, I could subtract row 1, but I'm going to actually do it a little bit differently to keep my format. So I'm going to add the negative in right here. Okay, so now look at what happens. 2 minus 2 times 1. That gives me the 0, right? And again, row 2 is going to be replaced by this operation. So let's see how this plays out. All right, so if I put a minus 2 on row 2 like this, so notice this minus 2 here corresponds to this minus 2, right? And then I put just a coefficient of 1 there. You don't have to put it there, but you can. What am I going to get when I do this row operation? So 1 times row 1 minus 2 times row 2. I'm doing this procedure, right, across all positions, all right, to replace row 2. Okay, so everything I do is going to end up right here, right? Okay, so let's follow this formula and fill out row 2. All right. 1 times row 1. Let's do it in the first position. 1 times row 1 is 2, and then minus 2 times row 2, right? So 1 times 2 minus 2 times 1. That gives me the 0, and that was my target, right? That's a row 2 there. Okay, so keep going. So we've accomplished one big task, is that we wanted a 0 here, we've got it. Now we've just got to fill out the rest of the row. We don't care what ends up happening, we just have to fill it out correctly. So let's follow the pattern established by our chosen row operation. Okay, 1 times row 1. Now moving on, we've moved on to the second position. 1 times row 1, which is 3, minus 2 times row 2, which is minus 2. I'm just going to write that to the side. 1 times 3 minus 2 times minus 2. Now what's all that? That's just 3 plus 4. That's 7. All right, so check. Now move to the third position. 1 times 0, right? Minus 2 times negative 1. Let's write that out. 1 times 0 minus 2 times negative 1. What's all that? That's just 2, right? That's a 2. All right, so we put a 2 there in the third position of row 2. All right, keep going. 1 times 1 minus 2 times 0 is 1. 1 times 0 minus 2 times 1 is minus 2. 1 times 0 minus 2 times 0, that's easy, that's 0. Okay, so we filled out row 2. So this row operation has taken care of row 2. Okay, now while I'm looking at it, let's just fill out. So next we're going to do row 3, but just before that, let's just write in row 1. Okay, we're not going to replace row 1 with any row operation, so let's just copy it into its the row 1 position down here in the matrix. So just copying down row 1. All right, so I just took row 1 and copied it right there. Okay, so now what we want to do is choose our coefficients for our second row operation. Okay, so let me erase my old coefficients. All right, so choosing now. Okay, row 1 and row 3, how can they combine, right? So we've got row 1 and row 3. How can they combine in order to get me a 0 right there? That's what I want. I want a 0 right there. Right? That's my goal. I want to have all zeros on the off-diagonal positions in column 1. So I want a 0 right there. How can I combine this 2 and this 2? Oh, that's easy. I just subtract. So I'm just going to subtract. Okay? So the way I write my row operation is just put a minus sign between row 1 and row 3. And that subtraction of rows is going to replace row 3. So 2 minus 2 gives me the 0 that I want. Then 3 minus 0 gives me 3. 0 minus minus 1, that's just 1. 1 minus 0 is 1. Right? 0 minus 0 is 0. 0 minus 1 is minus 1. So that was fast and easy. All right, so moving on. Next we want to choose row operations that are going to take care of column 2, right? So the column 2 contains a couple of 3's here that need to be changed into zeros. All right. So let me write down, make a note that I'm working on column 2 now. Okay. My rows that I'm targeting are what? Right? I'm the row 1 and row 3. Right? So again, I want to knock these two 3's out. Right? And I'm going to use that 7. Right? I'm going to use that 7. Now, this is where PatrickJMT got into a little bit of trouble introducing fractions. Because what he did is, the numbers don't look nice, so he just divided by 7 to get a 1 in the diagonal position, and you don't really need to do that. What you can do is you can use the LCM of 3 and 7, which is 21. LCM, I'm sure you're familiar, but just FYI, it's least common multiple. So the LCM of 3 and 7 is 21. How can I use that? Well, if I can get a positive 21, I can multiply by something, say 3 here, to get a positive 21, right, in this position, and then subtract a 7 times 3 to get a minus 21 in this position, then I'll get the 0 that I want, okay? So check out how that works. Like if I use these coefficients like that, okay? 3 times 7 minus 7 times 3, that's 0, right? So let's see. Let's see how this row operation is going to work. All right, so I'm talking about replacing this 3, which is in row 1, right? So I'm going to multiply 3 times row 2, then minus 7 times row 1, right? I'm using row 2 again. I'm using the 7 in row 2 to knock out that 3, right? All right, so let's do it. Starting with the first position, 3 times row 2 minus 7 times row 1. That's 3 times 0 minus 7 times 2. That's minus 14. So that goes in for the first position of row 1, right? Okay, keep going. 3 times 7 minus 7 times 3. That's the 0 that I wanted. Right? 3 times 7 minus 7 times 3. That's the 0 that I wanted. Okay, keep going. 3 times 2 minus 7 times 0. That's 6 right there. 3 times 1 minus 7 times 1. That's just 3 minus 7, which is minus 4. 3 times minus 2, which is minus 6, and then minus 7 times 0. So I get a minus 6 here. And 3, 0, minus 7, 0. That's just a big 0, right? All right, so that took care of that, right? Now row 2 just needs to be copied down, so let me do it. 0, 7, 2, 1, minus 2, 0. All right, so what next? This row operation, right? This row operation is going to replace row 3, right? But we haven't even written down what it is. So it's going to be, right, row 3 is going to go here, right? Because again, I just copy row 3 over there, like that, right? Just like I did up here, okay? And then row 2 is going to be the row that I'm using, right? All right, so how do I combine row 2 and row 3, right? How am I going to use this 7 to knock out this 3? So it's going to work in exactly the same way, right? So I'm just going to get a minus 7 down here now, right? So do you see how that's going to work? Because what's going to happen? I'm going to get 3 times 7 minus 7 times 3 to give me the 0 right there, right? 3 times 7 minus 7 times 3 is going to give me that 0 right there, right? And that's what I want. So let's go ahead and apply that across all of row 3. So 3 times 0 minus 7 times 0 gives me 0. 3 times 7 minus 7 times 3 gives me this 0. Mission accomplished. 3 times 2 is 6 minus 7 is minus 1. 3 times 1 minus 7 times 1 is minus 4, right? Follow my pen. 3 times minus 2 minus 7 times 0 is minus 6. 3 times 0 minus 7 times minus 1, that's a positive 7, right? So that takes care of column 2, right? Okay, so now we need to identify 2 more row operations that are going to knock out column 3. Okay, so let's quickly identify row operations that are going to make this happen. We're trying to knock out the off-diagonal terms in column 3, and those are the 6 and the 2. Okay, so let's identify the row operations. So we're targeting rows 1 and 2. Right? So copy those down, row 1, row 2, and we're using row 3 now, right? We're using row 3 to accomplish our goal. So these are computations to knock out column 3. All right, so how are we going to use row 3 and row 1 to knock out that 6? Okay, so it's actually pretty nice because we have a -1 here in row 3. So what we could consider doing is just multiplying that row by a 6, right? If I do that, then I get a -6 in this position, and then I add the positive 6 there, right? So why don't I just do that? That looks good, good as anything. So 6 times row 3 plus row 1. And then you see, actually, I'm going to be able to do a similar move to knock out the 2 in row 2. So if I multiply 2 times row 3 and then just add row 2, I get the other desired 0. All right, so let's follow our first row operation. 6 times 0 minus, minus 14. So 6 times 0 plus a -14, right? Following this formula. 6 times row 3 plus row 1. That's 6 times 0 minus 14 is what that is, all right? Or plus -14. So what's that? That's minus 14. And that replaces my row 1, right? Okay, keep going. 6 times 0 plus 0, right? 6 times 0 plus 0 gives me 0. 6 times minus 1 is -6, and then plus positive 6 gives me the 0 that I was desiring. Okay, keep going. 6 times minus 4 is minus 24, and then plus a -4 gives me a -28, right? 6 times minus 6 plus another -6 is, that's -36 minus 6, or minus 42, all right? Then 6 times 7 is positive 42 plus 0. So I'm left with a 42 there. So that took care of row 1. All right, now let's knock out row 2. So now what I'm going to use is a 2 here, right? Okay, so 2 times 0 plus 0, right? 2 times row 3 plus row 2. So 2 times 0 plus 0 is 0. 2 times 0 plus 7 is 7, right? 2 times minus 1 plus 2 is the desired 0. 2 times minus 4 is minus 8, plus 1 is minus 7. 2 times minus 6 is minus 12, minus 2 is minus 14. 2 times 7 is 14, plus 0 is 14. All right, then what happens? I just copy down my row 3, right? My row 3 just gets copy pasted right here. And we're almost there. We're almost home. Okay, now look what we have. We have something over here that almost looks like the identity matrix, except for that we have non-1s on the diagonal. So we want to get all those diagonal elements to be 1s. Notice that we did pick up some very large numbers, not very large, but moderately large numbers here, 42 and so on, and that's because we decided to avoid fractions, okay? So let's finish this off. Here are our row operations. Okay, so these row operations are designed to get ones across that diagonal so that I truly have an identity matrix on the left-hand side. So let's follow through with them. All right, notice I'm multiplying by negative 1 over 14 in order to transform that negative 14 up there into a 1, right? So I get 1, 0, 0, 2, 3, 3. So, no, sorry, negative 3 on the end there. Okay? Now, the 1/7 is designed to change that 7 into a 1. So I get 0, 1, 0, minus 1, minus 2, 2. Right? Next, this minus sign is going to change the sign of everything in row 3. In particular, it's going to change that minus 1 into a 1 as desired. So 0, 0, 1, 4, 6, minus 7. Okay, so the conclusion is that A inverse is the matrix that we see here on the right-hand side of that funny bar in the middle, the augmented matrix. 2, 3, minus 3, minus 1, minus 2, 2, 4, 6, minus 7. And that's really all there is to it. Check it out.